Okay, this is just a quick overview video. Here we have the cell, got a 12-inch steel rule on top of it, gives you an idea of size. The reservoir mounted above the cell, and the electrolyte goes down into the bottom of the cell, through the different cells into the generator, I guess, through the different cells, and then exhausts back up near the top of the reservoir. So you got the water pressure helping to force the electrolyte round through the cell, and then a lot less pressure when it's coming back, so it sets up the flow in that direction. That's also helped by having one end of the cell slightly higher than the other, because the bubbles are then going to go to, in this case, the left hand end up the tube, and that's going to also help to promote flow around it. Cabling, I've got two cables come along here, and I am going to use a TIG set to drive it. So there's the handset and the ground connected onto the wires. That's it, as you can see. Got a couple of bubblers in the background, so the gas will come out down there into one bubbler, from that into the next one, and then from there it's got a port I can close off, and that's where I take my gas measurements, and then that goes into the measuring device. Now there's an air gap at the top of the measuring device so that it doesn't empty the water out every time. The first graduation, or the 250 level, that first one is larger to allow for that air gap, so I've taken that air gap into consideration. So it's from the water level down to the 250 level, and then that gives you 250, 500, 750 and 1000 near the bottom. This is a 1 litre smart water bottle from Safeway. I've taken most of the label off just so that I can put the graduations on it and it's not all cluttered up, because they've got a big label. So anyway, what I'm going to do is, as you can see, I've got the meters running, there's nothing on there. I'm now going to switch the set on, which is here. It's a MIG and TIG set, so I'm going to switch the puppy on and you'll see what happens. I don't know whether you can see the speed of the flow here. This set, or this generator, doesn't chug the gas through like a lot of them do. The flow is smooth and fast. It's got some bigger bubbles mixed in with it. You can see those going past, but you can see the speed of the flow. So obviously if I increase the amperage, that flow is going to speed up as well. At the moment that's on 12 volts, 12.7 volts, and get the flare off it. It's drawing 10.5 amps, and again, they say you can hopefully see the speed of the flow. What I'm going to do is I'm going to turn it up a little bit, and you can see the gas going through the bubblers. Let me turn it up a little bit, and I'll try and leave the meters on. I'll take it up to, let's say, 13.8, which is what everybody seems to use. 13.75 volts. Oh, sorry, 13.18. And that's drawing 13 amps now, and the flow is getting a little faster, but as I said earlier, you know, you can see how constant this is. I'll turn it up a little more. .8, and at that it's drawing 18 amps, 13.8 volts. Shop temperature is about maybe about 60. Let me change that to temperature and then plug this puppy in. It's difficult doing this everything one-handed. 58. There's the probe there. 58, 57, 58. So it's about 58. What I'll do is I'll put the probe into the port there. Oops. Yeah. Put that probe into the port. And that's the gas temperature, 57. Now this cell typically will operate at all the time at ambient. Or maybe a degree, maybe 2 degrees above sometimes. But it's very, very cool running cell. Let me see. Let's see here. I can't time it and do this and hold the camera. But maybe, you know, you can time it. Say up to 250s, probably about 10 or 11 seconds, something like that. So anyway, I'll try and get this video on the site, or I'll put it on YouTube, something like that. Okay.